Okay, so this is a quick video just going over the regression model for the Major League Baseball. What I've done here is I have just kept 2 years of data, so just 2017 and 2016. We just lump it all together, nothing more fancy than that. And I've labeled it as reduced data. And what I'll do is also copy that to another sheet, and that's for the second part of this question. So here we go, and so that's for part B, the other sheet I copied. Escape. Right. So what we have is a independent target variable R, which is the actual number of runs, and we want to predict runs using singles, 2 base hits, 3 base hits, home run, base on balls. What was that? Yeah, BB, SB, and CS. Okay, so let's go back. BB, SB, and CS. And so we won't use those two, so I'll get rid of them just to make it a bit easier to highlight columns and things. Okay, so these are all the variables I'm interested in, and our target variable I'll put in a nice lime green. Right, so what we want to do is produce a regression model. So we need to go to data, we need to go to data analysis and do regression. And the Y range is L, and the X range is all these guys. And hopefully it'll work. We want labels, and that's probably enough. And at this stage, so let's go OK and see what happens. Okay, it doesn't like, again, doesn't like the fact that I've highlighted the whole L cell. So that's going to be, let's get rid of that. Let's start again. Where does it finish? It finishes at 61. Okay, so let's do it again. So data analysis, regression, input range, so that's L1, L, let's just highlight the actual cells, L1 to L, it's annoying, isn't it? Oh, there it is, going the wrong way. L1 to L61, and this is the independent variables, so we want all of those. And so we've got the cell ranges highlighted, and now let's say OK this time. And we get our regression model. All right, so let's, can we make that bigger? View, zoom. A little bit better for me to see. All right, so we have these coefficients this time round, and the coefficient for home runs is roughly 1.5, which again is very, very close to what Winston got. The p-values are all pretty good, apart from SB and CS. So even that's close to 0.05. So I would definitely keep that one in, but these two, oh no, the last one is about the same, but yeah, SB, stolen bases, you could probably easily get rid of from the model. What else? We can see how much variation is explained. So about 90%. What else can we see? That's probably about it. What are we asked to look for? Please don't remove any models, so we won't. How well does your model agree? We'll have a look at the coefficients. How much of the variation is explained. Look at the R-squareds. And do the same thing again. Oops. So if we go to the modified reduced data, the second case, and we want, in that case, there's our dependent variable in green, and this time round we want to get rid of all those other variables. And so we want to get a model in terms of just on-base percentage and slugging, and which are tabulated just for those 2 years. I'm going to do it, but you have to do it for all the given years. Was it 2010 to 2017? So let's build our regression model. So let's go to data, solver, close that, solver, data analysis, regression. Okay. So we want, in this case, we want G down to there, and the input range, we want that down to there. So that block of cells, that's sort of why I got rid of the other columns, just to make that an easy sort of thing to do. And let's say OK, and blow it up. And we can see our model comes up with, I think, pretty similar stuff. But remember, this is just based on 2 years. But you can see here the coefficients. The on base is roughly twice as important as slugging. Does that agree with Winston? I can't remember. Have a look. And the p-values, they're all highly significant. And the R-squareds are slightly less. Okay, so that's probably an observation worth making. This reduced model with these aggregated sort of aggregated variables explains less of the variation, but not too far off. Okay, so I think that's probably enough for this question. And if you want to have another look at what I've done, go back to the video, the class video, and have a look, because I covered pretty much the same thing there, but I might have said something slightly different. So anyway, check it out.